Alright, in the end of the last video we were going through the analysis of this circuit. If you haven't seen the previous one, then go to that one now, otherwise this one won't make a lot of sense. So let's continue. We'd found this one and this current, total current around the circuit, and that came out to be 0.8 amps. And we found also the voltage potential difference through resistors 1 and 6, and we labeled them here. This was 1 and this was 6. They were the first and easy ones to find. The potential differences came out to be 3.2 for 6 and 4.8 for 1. And then we found the potential difference that has to be left. The last drop, which is through this one and this one, has to be equal to the difference between 10 volts of EMF and those two resistors. These three drops have to equal 10. So we just did 10 minus the 2 we found, and we had 2 volts. So 2 volts has to be the potential drop from this point to that point. This is what we drew here. Now, how is that useful? Well, if I know that there's 2 volts from here to there, then I can find all the information that I need regarding the currents that are gonna go through these three. So let's find the currents I1, I2 and I3, and then once we have those three currents, we can find the potential differences individually through these resistors. I hope you can see that the potential difference through the resistor up here and down there are just going to be the full 2 volts, because it's the same potential difference through each of the parallel branches, right? I explained that in the last video. We've used that principle a few times. So the V resistor 2, V2, and the V through resistor 5, these two we already know from just analyzing the circuit. We can actually know that this is going to be already 2 volts from what we know already, and this is 2 volts also. So actually we only have to find the potential difference through these two and the current through the three of them, which is up here. Okay, so I'm going to do a little zoom to what's going on there so that we can have a bit more neater situation. And so what are they? Are 8 ohms, 2, 4 and 10. So over there we had 8 ohms, 2 ohms, 4 ohms and 10 ohms. And we know that the potential difference between this point and that point we said was 2 volts. So what is the incoming current? We calculated it before, and the current going around the whole circuit, which is going to be the same one here and there, and not in these three because it divides, but definitely as it comes in, was the 0.8 amps that we have there. So we know that that is 0.8 amps. So let's figure out how much of that splits through each one. Let's see. So the potential difference through each of these branches is 2 volts. So there we have a resistor which with a resistance of 8 ohms. So if we use the equation V is equal to IR across that resistor, which essentially would mean that we're going to put a voltmeter through there to see what we read, what do we get? We get the current, which is an unknown current, which we want to find out. So let's do V over R like that. So that's going to be the voltage potential difference across the whole resistor, which is 2 volts. In the three branches it is 2 volts, so that's 2 over the resistance, which is 8. So that is equal to 1/4 of an amp, 0.25 amps going through that one. What happens through this one? Well, let's do the bottom one first. So that is current through resistor, well, I don't know what the name of that one was, resistor 2. So now we know this guy, 0.25 amps. Now let's go to the branch, the current through 2 and 3, the branches 2 and 3. So what is the current going through this one? Well, the total resistance through these two resistors is 6 ohms. So I going through there is going to equal the voltage drop through both of them over the combined resistance. So the voltage drop is still 2 again as in the one above, same, and the resistor is now different. The total resistance is 6 instead of 8, so the answer for the current is going to be 1 over 3 amps, and 1/3 of an amp is bigger than 1/4 of an amp. Why am I getting bigger current through this branch than through that one? Well, because here I've got 8 ohms and there I've got 6 ohms, so there's a greater impedance, so greater resistance to the current here than there, so the current is slightly smaller here than there. And this is 10 ohms, bigger than both of those, so in theory we should get a smaller current even for this third branch. So we've got those two. We've got this was the current number 2, this was current through sorry, this was actually I call that current branch number 1, even though it's resistor number 2, sorry about that. And the current in branch number 2 we just found out, so we now need the current in branch number 3, and we're closer to knowing everything about the circuit that there is to know. So I3 is going to be again the 2 volts at the top and at the bottom 10 ohms. So that is 1/5 of an amp, and that is the smallest out of all, that's 0.2, right? So this is 0.33, that's 0.25, and that's 0.2. So this is the smallest current, which makes sense because that's the biggest resistance compared with these 6 combined and that 8. And so now we have I1, I2, and I3. So what do we have left to find? Let's see. We've now found I1, I2, and I3. We're only missing V3 and V4. What were V3 and V4? Well, this is resistor 3 and that's resistor 4, so we wanted to know the relative potential drops through these two. So that's the same thing as asking if I put in a resistor here, sorry, I have a voltmeter here, and I put another voltmeter there, then what are my readings? So this is resistor 3 and resistor 4. We called them 3 and 4 before. So let's find out V3 and V4, which are the last things to find out. Well, the total drop is 2 volts. So whatever we get here needs to add up to 2 volts, and that's a good thing to know, because when you get the answers you have to add them in your head, or look at them and see if they give roughly 2 volts, and then you've done it right. If they give you 7, then you haven't. What is the current going through the second branch? Well, we just calculated it. This one here is 1/3 of an amp. So if I want to know the voltage going through that resistor, then across that resistor, the formula is V is equal to IR. So V3, which is, sorry, that would be V4. V4 would be equal to the current, which is 1/3 of an amp, times the resistor. Resistor is 4. So that would give me 4/3 of a volt. So 1 1/3 volts for V4. What about V3? V3 is going to be the same current that's going through one resistor, is going through the other, because the current's conserved. Same current times a different resistor, which is just 2 ohms instead, so that's 2/3, right? So we've got 2/3 of a volt plus 4/3 of a volt. What do we get if we add them? Well, 4/3 plus 2/3 is just 6/3, and that is, in my books, 2 volts. So we've got the right total for the total of the potential drops that go through here, which should give us 2 volts. And we now have the potential difference across each of all the resistors in the circuit. So we know everything about the circuit. We know this potential drop, that one, this one, this one, this one, that one, and we know the current going through all the circuit and the current through each of the branches. So we figure out everything. Hopefully the methods make sense, and the explanations have been clear enough. Alright, so hopefully that helps a little bit with your circuit theory. I'll see you in the next video.